Welcome to Chapter 3 of the Technician Training Series, Fundamentals of Dyes and Dyeing Chemistry. This chapter is part of the Textile Lab training program. In this chapter, we will cover 5 key areas: the types of dyes for each fiber, how dye bonds to fabric, selecting dyes based on end use and cost, common dyeing problems from wrong selection, and valuable lab manager tips, and a quick cheat sheet. Different fibers require specific dye classes. For example, cotton uses reactive, direct, or vat dyes. Polyester needs dispersed dyes. Nylon typically uses acid dyes. Knowing your fiber type is essential for choosing the correct dye class. Reactive dyes are widely used for cotton fabrics. They form strong covalent bonds with the cotton fiber, which results in good wash fastness. The process involves adding salt and alkali to create the covalent bond. A wrong pH can prevent the dye from fixing onto the fabric. Here is a quick look at other major dye classes. Direct dyes are simple and economical but have lower wash fastness. Vat dyes offer excellent fastness, but require a reduction process. Dispersed dyes are for polyester and applied at high temperatures. Acid dyes are used for nylon and wool, bonding with amine groups and requiring a pH of 4 to 5. Dyes stick to fabric through various fixation mechanisms. Reactive dyes use a strong covalent bond. Direct dyes rely on weaker hydrogen and van der Waals bonds. Dispersed dyes sublimate into the fiber. The correct dyeing parameters like pH, temperature, and chemicals are critical for forming these bonds. The reactive dye process on cotton involves 5 steps. Load fabric, add salt to push dye onto the fiber, add alkali to form the covalent bond, maintain the correct pH, and achieve good fixation and exhaustion. Correct pH is vital for bright color and strong bonding. Selecting the right dye requires considering fiber type, fastness requirements, cost balance, and end use. Always match the dye class to the fiber, end use, and buyer standard to ensure quality. This decision table illustrates dye selection examples. For a 100% cotton t-shirt needing high wash fastness, reactive dye is suggested. For a CVC blend requiring good rub fastness, a reactive plus disperse combination works. The real decision balances fiber, buyer specifications, cost, and machine capability. Wrong dye selection leads to common problems. Using direct dyes on export knits results in failed wash tests. Low migration dispersed dyes on polyester can cause uneven dyeing or streaks. Using a weakly substantive reactive dye on heavy fabric often leads to patchy dyeing. Wrong dye selection equals failed bulk production and buyer complaints. Observe these visual examples. Incorrectly using direct dye on an export knit results in a failed wash test. Applying dispersed dye at the wrong temperature on polyester causes streaks. Correct practice, such as reactive dye on cotton or dispersed dye at 130 degrees Celsius, ensures bright, level shades and meets fastness standards. Train your team to recognize these differences. Before every dye selection, lab managers should check the buyer's technical specifications, verify machine parameters to ensure they meet dyeing requirements, and check dye compatibility, especially when mixing dispersed dye brands. Always confirm dye specifications with the supplier, as strength and fastness can vary by lot. This quick cheat sheet summarizes dye selection by fiber. Cotton needs reactive dye, alkali, and salt. Polyester needs dispersed dye and high-temperature dyeing. Nylon uses acid dye at a low pH. Wool uses acid or metal complex dye with a gentle temperature ramp. Print this sheet for quick lab reference. The key takeaways for Chapter 3 are: choose the dye class based on fiber type and end use. Understand the bonding mechanism for troubleshooting. Always confirm dye specs with suppliers, and keep reference cards for quick checks. The right dye plus the right process equals first-time right bulk production. This concludes Chapter 3. Up next is Chapter 4, Working with Dyes, Balancing Cost and Quality. Remember these 3 fundamentals: know your fiber, know your chemistry, and know your buyer specifications. Thank you.